Yeah, Ben is sharing the slide. So MGL is an open software MATLAB-based visual experimental software package for macOS that a few of us wrote while we were postdocs in David Huger's lab at NYU. It's been stable for over 15 years, and we and others have used it in over 100 publications. The library is essentially split into two parts. One part with atomic MATLAB MEX functions allow for display to the video frame buffer using OpenGL, digital and analog I/O using National Instruments cards, interfacing with iLink, eye trackers, and automated gamma table calibration using photometers and colorimeters like Minolta and the PR650. The task library allows for rapid development of trial-based experiments in MATLAB and is closely integrated into another MATLAB-based library that we wrote, MR Tools, that we use for analyzing fMRI experiments that has implemented analyses for things like PRF and event-related designs. Next slide, Ben. A few years ago, Cupertino began uttering my least favorite word in the hacker lexicon about OpenGL, deprecated. And so in December 2019, I spent the better half of the Christmas holidays coding an alpha version of MGL based on Apple's Metal library, which is their replacement for OpenGL. This alpha version lay dormant for a few years until VJ and MathWorks came to the rescue with a community project and supported Ben Heasley, who will talk next, to flesh out this alpha to a release version. And I now will be transitioning my lab over this summer to use this metal-based MGL. Apple's Metal library does have many benefits, I think, for a community. For example, it provides a well-defined and robust way to dig down into the graphics card on macOS to implement things like very high-speed displays needed for, say, white noise stimuli or frame-by-frame accuracy for EEG experiments. One other advantage is access to high dynamic range or deep color, something that we were never able to convince OpenGL to do on macOS, meaning that if you increment the value of gray that you set the screen to in small steps of 1/1024 and measure the monitor output with a photometer, you get step-like changes in luminance as in the graph on the left because the pixel format is limited to 8 bits. But with the new MGL Metal version using a high bit depth pixel format, I was able to measure just last week a smooth gradation of luminance output showing the true 10-bit luminance resolution, which is necessary for psychophysical experiments in which luminance or contrast thresholds can be below 1%. Now on to you, Ben.
Hi, thank you. I'm Ben Heasley. I'm an independent developer working as Triple Dip LLC. I've been working with Justin, who you just heard, and BJ, our host, and Eli Merriam at NIH on this new version of MGL. So yeah, on macOS, OpenGL is no longer the way forward for graphics. We looked at a couple other APIs that are available. One is OpenGL ES, so like the mobile or web version of OpenGL. That is available via a compatibility layer called Angle. There's also Vulkan, the successor API from Kronos Group. That's available on Mac via a compatibility layer called Molten VK. But we decided that on Mac, all roads lead to Metal. So let's use Metal for the new version of MGL and see if we can take advantage of some of the. So to do this, the design of MGL has changed a little bit. So I'll overview that. As an experimenter, as a user, you should see the same familiar M-code functions that you might have seen if you used MGL version 2. So a lot of those functions have been updated and are now working with version 3 with Metal. Underneath, MGL is no longer making direct OpenGL calls. Instead, it's making socket calls, and it's communicating with a standalone process that we call MGL Metal. This is a simple macOS app that has just two jobs: to listen for commands on a socket and then do rendering with the Metal API. Because it's a pretty simple app, we're able to ride the rails of macOS development with Xcode. And since we're going all in, we might be able to take advantage of some really nice tooling that Apple developed for using Metal with Xcode. One example of this is you can connect to a Metal process and inspect and debug a running shader program, which is not always easy to do. So as we achieve feature parity with previous version of MGL and then go further to explore deeper parts of the Metal API, this kind of tooling should be really useful. Finally, a snapshot of where we're at with the V3 development process. We've done, we think, the bulk of the work to re-implement existing draw commands that were OpenGL and are now Metal. So that's great. We're also talking about what to do next. And so I want to call out 3 areas that we're looking at next. One is eye tracker integration. And this would include things like live eye images being rendered in the MGL drawing window. Another one is, so this will look a little different than it used to, but it seems achievable. And we would think about things like stimulus scheduling or synchronizing between displays. And finally, supporting movies. So we have use cases where we want to have a playing movie and then draw graphics on top of that. And so that's something else that we could pursue next. And thank you very much.